I'm very excited to introduce Dr. Ali Naqvi, who's written quite a bit for us here at GovCI Media and Research, and he's going to talk a little bit about multi-thinking, rethinking AI for national priority. Excuse me. But yes, he is the CEO for the American Institute of Artificial Intelligence, and like I said, very excited to have him teach the last session. Okay? All right. Off to your new. Yeah, use that one. Perfect. All right.
Hello. So last session, that means I have the responsibility to make sure that we thank Mike Hoffman for organizing this. GovCIO does a wonderful job, and GovCIO Media, if you have not been reading their articles, they're phenomenal articles. Not because I write some of them, but they are. And I also want to thank this team that does great work. I'm from an institute, so I know what it takes to put this together. Most of all, people like me who are just delay sending their presentations, and these guys probably feel like saying, send me the damn presentation, you lazy bum. But they are so polite that they express it more. Dr. Naqvi, can we please have this presentation? We're running out of time. So thank you so much. Big round of applause for this team. So we started the session this morning with soft tech, or how easy it is to do automation. And these days, you can just go in and do this information, check this, do that, small tasks. I will talk a little bit about how hard it is, because let's talk about hard tech. And our government obviously needs some of that. So let me start by introducing our institute. We're the only institute in the world which is exclusively focused on national security AI. And our mission is to help improve the national security of the United States. And I'll come back to this mission explaining to you why a GovCon like us is also an educator and a research institution, because that's the need of the hour. So what makes us different? We tackle hard problems. We focus on very complicated problems, signals, engineering, advanced mathematics problems. That's why our specialization is in mathematics, as well as we bring what we call authentic AI. So there's a lot of AI out there, a lot of companies who have just deleted the BI from business intelligence, replace it with AI. But there is authentic AI, and we claim because we're an institute, as one of those. Actually, we have this perspective that science started in, say, 17th, 18th century with empiricism and rationalism. Some of that we need today, actually. And then you see 18th century as science developed, and 19th century, and then 20th century, a lot of different models came out in science. But today, we are in the age of what's known as computational epistemology, or post-science era, because AI, complexity theory, and quantum, these are the three forces that are defining our world and what is possible in science today, which we never had before, because knowledge can be created through machines. And this gives us at AII a sense of awareness that we need to constantly think differently. We have authored several books, unlike several GovCons who try not to contribute. We recognize that if we want to help the United States, two things we absolutely must do, besides being just a GovCon, is to publish books, publish research, so that we can upskill other people to learn AI. This is not an easy thing, and these are not ordinary times. These are defining moments that will define where we will end up as a nation 10 years from now. We also have worked on very large, complex problems, including signal characterization, national strategy for AI, so you can see different kinds of projects we have undertaken. And we, on the commercial side, we have established relationships with literally who's who in America. in professional societies, including AI CPAs, the CPAs who do your tax returns, and American Marketing Association, supply chain organizations, as well as National Defense University. And we have our own certification program. Again, this is a very different kind of GovCon. Now I'll explain to you why research is important for us and education. Because AI changes on a daily basis. People said here AI changes, it's rapidly changing. I am telling you that it's changing every day. New papers come out every day. Research has to be part of GovCon, responsible GovCon organizations. And publication and education needs to be part of that so that we can constantly upskill our people if we want to compete effectively in this geopolitical situation. Adversaries, let's not be in denial. They are working on AI. They're advanced in AI. And it's no longer, we cannot say that we're number one in the world, as you saw with DeepSeek. So competition is out there. That's why it is strategic, it's existential in a way, this competition. So unfortunately, our approach to, and that's why I said that we will talk about hard AI, hard problems. Our approach to AI, and you heard a lot of that, is use case centric. Let's find some use cases, and somehow these use cases will come together and we'll have this, superb AI that will automate everything. This is the kind of mindset we saw with BPR movement, business process reengineering movement, in which a lot of software came out, and then all of a sudden we said, oh wow, we have to throw it all out and start building ERP-based shared services model. That's gonna happen 10 years from now. If we don't think right now, that's the future of what will happen. We'll have to throw out all this. Now, a little bit improvement is from use case-based mindset is linear task mindset, in which we analyze a process and we say, okay, task 1 needs to be automated, then task 2 needs to be automated, then task 3 needs to be automated. But really, these both they fail in different ways, and I'll explain why. So let's talk about what a process is. A process is simply a goal-oriented assembly of work. So you have something happens, you see on the left side, it's something that gets produced out of a farm, that raw material that goes through a ship, onto a truck, onto some manufacturing, then gets packaged, and then loaded again, and then delivered to retail. That's a process, essentially. So and task is one part of it. For example, loading a package in a truck would be considered as a task. It's simply a unit of work chain. So we approach automation as a collection of tasks, each needing to be automated. The reason we're doing that is because this is a leftover from the 1990s Hammer and Champy business process reengineering movement, in which we went through the first scale of automation that is here today. Young people, I apologize, you would not know about this, but people who were there who implemented those ERPs and fought those battles, they would remember that what business process reengineering was. Well, use cases come out of these process automations, from these tasks. That's why we think in terms of use case. Let's just take this one use case and automate that, and something good will come out of it if we just start automating each one of them. So we connect these. We are either doing it randomly, okay, a random use case here, a random use case there, bring us a use case, okay, with supplier A, bring us another use case, supplier B. These use cases don't talk to each other. They have no sense of goal orientation or global optimization. Then what happened is what will happen is this is what AI we will be building, which is like, it's not a home. It has all the structures of home, has a kitchen, it has a bedroom. Sometimes I wish when my kids were learning music, taking music classes, that I had this setup, which would have been very helpful. But the way we need to build AI is like this. We gotta have this architectural orientation, that how these things will come together. What we call use cases, a use case here, a use case there. And that's what, so when we come in, we look at automation, we say, okay, we'll just put in the first automation, single task, then another single task automation, then another single task automation, and it just flows through. This is the model that is set for failure. I should say that. And as an expert, I am telling you that because I have studied Chinese model, and I've actually authored a book on that. So meet Atlas. I call it Atlas because it acts like that, like Atlas. Never shrugs though. It knows how to do one task and it does it really, really well. But there's a problem with that. Single task learning is expensive, it's risky, and it's brittle. It fails to leverage learning that can happen across multiple processes, and it's optimizing parts, not optimizing the ultimate goal. So STL is a linear task-oriented process. It's a task-oriented model, again, which just learns from one given task, from one given set of data, and then the next one, and the next one, next one. But it has no concept that there's a fourth task out there that I can learn something from. And this goes counter to, especially in military applications, goes counter to multi-domain joint forces model, because decision-making in joint forces model, by definition, needs to be globally optimized, right? It's not that, oh, okay, Navy makes this decision, Air Force makes this decision, and somehow this decision will be optimized. No, it doesn't happen. So sense of autonomy requires global optimization perspective. And then this can actually lead to, as I mentioned, global optimization, not helpful, high overhead in orchestrating these, maintaining these. Eventually 10 years from now, as I mentioned, that 5 to 10 years from now we'll be like, okay, this is just too much overhead. We need to go and develop some kind of a multitasking model. So welcome to multitasking, which means that can I use one model to do a lot of things? Now, autonomous cars, in your mind, would be something like, okay, it is a combination of 500 different single automations that work together. That's not the case. It's multitasking. It learns one model that's learning a lot of things. That's how it works. So think about building AI that is multitask-oriented, one model that can do multiple things. And also when we think about processes now, this is a little bit complicated, but I'll just explain it to you. When you think about processes, forget about linear way to think about that. Well, business models are changing. Think about how AI can help us discover new types of use cases, or if we want to go use case path, which is non-linear. And AI can help you rethink, reimagine that part. So multitask learning is a human, it's close to how we think in terms of as humans, because we're cognitively trained to do that. You know, we'll put a block and then we'll put up another block on top and another block on top. So we understand that. That's how we evolved. But the thing is, this requires us to think differently. And I remember that from Interstellar, that thing about that how he's, if you have watched the movie, how he talks about that how space travel is possible is that that space curves and you can go through this, and that's how, you know, he explains that how space travel is possible so quickly. And now you know that how we can analyze data to discover those use cases just by looking at different ways this data moves and how it curves. So I can, you know, explain to you in another way is that the new mindset that's needed in America and government and businesses also, and businesses are adopting this, is that we need to shift from these single task use cases to multiple multitask learning models, wherever we can. It's not for everything. In certain cases, obviously, single task learnings are very good. But in multitask learning is the new model. These are holistic thinking models. You need one model, so cost goes down. But obviously training complexity increases a little bit. But still, it is the most efficient model. It is because it's learning from each other, so from each different task. And I'll show you on the text side a little bit, and it will become clearer. So we have a platform we call Polymath, which actually transforms linear processes into these advanced processes that are not confined by linear thinking, both in terms of process as well as in terms of automation. And then you can reimagine and reinvent processes, and then you can develop a multi-task learning model within that, and it is defense ready, obviously. So now I'll do a little bit of technical review, and this is if you don't have technical background, don't worry, because I'll explain it in a way that we will all understand. So this is your traditional, what's known as transformer architecture, which is used to train LLMs. So if you are Google or ChatGPT, you use this architecture to train large language models, transformer architecture, in which data goes in from the bottom. Then there's something known as position of data, how data is positioned, if word 1, word 2, word 3, word 4. So if data was sentences, and then position of first word, second word, third word, those are known as positional encoding is put in. And then you have attention heads that learn this learning that you see LLM, how it works, and then finally it sends that data to something on the right that you see, which is not shown here, decoder. It's a little bit covered at this point, and that's how your LLM works. Essentially, a little bit complex model, but that's how it works. So in an MTL, what's happening in multitask learning is, look on the top, I have one task, I have second task, I have third task, fourth task, fifth task, which is 4 of them are regression. If you are familiar with AI, 4 of them are regression, 1 of them is classification, but they're all working together under the same architecture. Same architecture used to train all of them, so now it's learning in multiple ways, and even decoder itself can be another task. So you don't need 5 different single task learners when you can have one that can train everything. And it uses a global optimization equation that you see over there. This is what it's trying to do, is to use that math to globally optimize everything. So all tasks can be learned, and uses the same backbone to get even embeddings. Embeddings can be used to do other things, so vectorization is possible. If you don't understand that, don't worry about it. This was meant for technical people, but look at what happens. This is a project that we actually did for AFRL, and it turned out to be amazing because using a single model, we were able to get these 5 tasks here. The first 4 tasks show regression, meaning that it learned regression. And the line you can see, it's going up as the data is, the lines are going up. And the fourth one, it learned how to do classification, all using the same model. That is the beauty of AI today. That is, so we're, as much as possible, we would like to see the government move from single task learning to multitask learning and move away from this linear single task automation. That's going to cost a lot, and in several years, I think that we will see a change that will happen in which they will have to switch. So our platform is usable for defense, as well as civilian agencies, and on the commercial side for industrial automation, which is also a critical part of U.S. national security, because national security, remember, is not just about weapons, it's also about economy, it's also about healthcare, it's also about environment, you name it. All this, everything when this comes together, that's what makes good, powerful nations, and that's what the goal is, to use AI to build that power base that gives us a huge distance between us and the next adversary on the ladder. And that's a goal, and hopefully that our combination of what we're doing and what all of us are trying to accomplish here, that will be the result. Thank you so much. I think I finished a little bit early, so I'm open to questions. Go ahead.
About how it works. I'm familiar with like foundation models and the basics of transformer architecture. But what you have, is that something that's based on a foundation model and you put it into a learning pipeline, or how does that?
That model that you saw, the lower model, is not trained. You're training everything together. So for example, if you're using a large language model, so our minds are only thinking about, for example, only on the language side training. But think about signals, right? How would you train a transformer architecture for signals processing? And the kinds of things that we do. In that, you can see that how the transformer architecture, the same architecture that's used to learn language, can also be applied to learn signals. And then you can have multiple multitasking on top of that so that it all becomes one system, and under same optimization, it's trying to learn different tasks, how to do different tasks.
So, but is your platform more for training a custom model from scratch, or is it for doing things on top of a
Custom model from scratch.
application development?
Application.
I'm used to using foundation models and then
Right.
somebody else doing.
We can use, obviously we can connect to foundational models as well, but essentially for other tasks. So primary hardcore tasks, that's something that LLMs can't do, you need another architecture that can do that.
You need a big company to implement this, or do you have anybody trying to do this right now?
At this point, we do have a big company as a partner. It's known as GovCIO. They do really good conferences. So they're our partner.
Cool. So this may be something tomorrow or something. I see what you're saying. Okay. Interesting. Because I've never seen that before, right? I've seen that part.
Yes.
One of the stuff on top.
That's exactly why I say that research is very important. You will get a lot of soft opinions about AI, but when it comes to real competition with adversaries like China and Russia, and I don't, so, at the end of the day, nothing matters except that your hard tech capabilities, your mathematics, quantum, those capabilities. So when we approach, we made sure right from the beginning that that's the model we'll keep. We can make more money going the other way, but we want to make sure that our mission is served, and that is served through research, education, and platform development that solves problems in a different way.
So this is kind of like state sponsorship. We know China's doing a lot, but then, we see these things about the president and all the hardware stuff and all these big players. You're saying this is something that the national, because to me this is like a national or a giant company effort, or maybe some research.
That is our goal. One day we want to become a giant company, a responsible giant company. All right. All right. Thank you. Appreciate it.